Yes, my friends. Now we have seen a random variable capital X is said to be takes the binomial distribution and with n comma p are the parameters where n is the number of trials, p is the probability of success. Then we have seen that mean of the binomial distribution is np and variance is npq, so that standard deviation is square root of npq, where p is the probability of success and q equal to 1 minus p, or 1 or p plus q equals to 1. Now we'll see some examples and problems on binomial distribution. Now we'll go for this example. A fair coin is tossed 6 times. Find the probability of getting 4 heads. So that means the coin is tossed 6 times. So the number of trials n equals to 6. And when I'm tossing a coin, probability of head is 1 by 2 and the probability of tail is 1 by 2. So here my probability of success is getting head. Probability of getting head. My success is here getting head. So p equals 1 by 2, then q is also 1 by 2. X is the number of success I required. So I required 4 heads. Out of n 6 trials, I required 4 heads. So n equals to 6, p equals to 1 by 2, and q equal to 1 by 2, x equals to 4. Then probability function for the binomial distribution, p of x equals to n cx, p power x, q power n minus x. So probability of x equals to 4 equal to 6c4, 0.5 whole power 4, 0.5 whole power 6 minus 4 is nothing but 0.2. 5, sorry, 0.2 whole square is nothing but 0.234 is the answer. Now we'll move to the another example. Out of 800 families with 5 children each, how many would you expect to have? First one, 3 boys, either 2 or 3 boys, 5 girls, at least 1 boy. So first of all, we are doing this problem for 500 families. So first of all, I'll take the 800 families we are doing. So capital N equals to 800. Now in each family, 5 children are there. So small n equals to 5. I'm assuming the probability of girls and boys both are equal. So I'm taking the probability of boys is equal to p equals to 1 by 2 and q equals to 1 by 2. Then first of all, what is the probability of 3 boys? So that means probability of x equals to 3. So 5c3, because number of success I required is 3 out of 5. So 5c3, 0.5 whole cube into 0.5, 5 minus 3. So is equal to 0.3125 is the probability of uh, uh, in each family 3 boys. Like that I have 800 families. So 800 into 0.3125, so approximately 250 families are there with 3 boys. Now, second one is either 2 or 3 boys. So p equal to either 2 or 3. So p equals to probability of x equals to 2 plus probability of x equals to 3. Now probability of x equals to 2 is 5c2, 0.5 whole square plus 0.5 whole power 5 minus 2, plus probability of x equal to 3 means 5c3, 0.5 whole cube into 0.5 whole power 5 minus 3. So the answer is 0.624. This is the probability of either 2 or 3 boys. Then total number of families are 800. So 800 into 0.624. So total approximately will get 500 families with either 2 or 3 boys. Now we'll move to the third problem, 5 girls. So total 800 are there. So small n equal to 5, probability of boys equals to 1 by 2, then probability of girls is also 1 by 2, probability of 5 girls. So probability of x equals to 5. So 5c5, 0.5 whole power 5 into 0.5 whole 0 whole power 0. So is equals to 0.0312. So there are 25 families with all 5 are girls itself. Now P probability of at least 1 boy. So probability of x greater than or equal to 1. Otherwise I can find 1 minus probability of 0 boys. So 1 minus probability of 5 girls. So 1 minus 0.0312, then 0.96. So 800 families are total. So 800 into 0.968. So there are total 775 families, or approximately, with at least one form. Now we'll go to the second problem. So for 6 trials, probability of x equal to 2 is equals to p of x equals to 6. In a binomial distribution, find the probability of success. So condition is given, probability of x equals to 2 equal to probability of x equals to 6. There are total number of trials are 6. So we have the formula, probability of x equal to small x equals to ncx p power x q power n minus x, whereas small n is a number of trials, small x is a number of success required, p is the probability of success, q equal to 1 minus p. So p of x equals to 2 equal to p of x equals to 4. So 6 is c2 p square q power 6 minus 2 is equals to 6c4 p power 4 q power 6 minus 4. So I'll get 6 15 p square equals to 15 q square, p square by q square equals to 1, p equal to q equals to 1 by 2. So p equals to 1 by 2 is the probability of success. Now we'll go for the next example. It has been claimed that in 60% of all solar heat installations, the utility bill is reduced by at least one third. Accordingly, what are the probability that the utility bill will be reduced by at least one third in 4 of 5 installations? Second one, at least 4 of 5 installations. Ah, solution. So probability that P is the probability that in the solar heat installations, the utility bill is reduced by one third, is 60%, is nothing but 0.6. Then P equals to 0.6, then P plus Q equal to 1, so implies Q equals to 0.4. So now first of all, we'll go for the first one, 4 of 5 installations. So if x equals to 4, and then what is the probability of x equals to 4? So we have small probability of capital X equals small x equal to ncx p power x q power n minus x. So probability of x equals to 4 equals to pi c4 0.6 whole power 4 into 0.4 whole power 5 minus 4. So 0.2592. Now second one is at least 4 of 5 installations. At least 4 means x greater than 4. So probability of x greater than or equal to 4. So the probability of x equal to 4 plus probability of x equals to 5. So we have already probability of x equals to 4 is 0.2592. Probability of x equal to 5 is, according to the formula, pi c5 0.5 whole power 5 0.54 whole power 0. So from this one, I'll get the probability is 0.337. Now we'll see for the original obtained from for original data. So what happened for the given data if we are fitting a binomial distribution? Now we'll see this. So here is the one problem is given x and their frequencies. X values are 0, 1, 2, 3, 4, 5, 6, and frequencies are 13, 25, 52, 58, 32, 16. 4 is the it's a original distribution. Now what happened for this data? If I am fitting a binomial distribution, so what will happen? Here small n is the number of trials. So the trials are 6. So capital N is the total frequency. So summation of f equals to 200. Now what is the mean? Mean equals to be summation of f of x by f. So 25 plus 104 because f into x. So 58 into 3 is 174. 4 into 32 128. 5 into 16 80. 6 into 4 24. Total divided by sum of frequencies 200. So 2.675 is the mean. Now, the mean of the binomial distribution is n into p. We have n is number of trials is 6 and p is the probability of success. Right. 6 into p equals to 0.675. So p equals to 0.446. And what is the value of q? Because p plus q equals to 1, then q equals to 0.554. Hence, the binomial distribution to be fitted as capital N into Q plus P whole power N. So 200 into 0.554 plus 0.446 whole power 6. Now, by using the binomial distribution, 200 into N 6C0 0.554 whole power 6 into 0.446 whole power 0 plus 6C1 into 0.554 whole power 5, 0.446 whole power 1. 6C2, 0.554 whole power 4 plus 0.446 whole square. So like that, if I'll expand by using the binomial expansion, then 200 into 0.02891, 0.1396, so on. Then frequencies are 5.782, 27.92, 56.18. So 3.32, 36.42, 11.728, 1.5732. So if we'll take the nearby integers, 5.78 I'm taking as 6, 28, 56, 60, 36, 12, 2. So this is the original frequency distribution. If I'm approximating this one with the binomial, then this is the binomial distribution. So when I'm doing this one, so capital N is the number of frequencies, right, and small n is the number of trials. So this is my original distribution, but this is when I'm fitting the distribution with using the binomial distribution, I'll get such distribution.